In the field of robotics, robot manipulators play a key role in all sorts of tasks, generally for apprehension and object manipulation. Furthermore, the continuous evolution of humanoid robotics has posed new challenges. Now is intended that the machine can interact with its surrounding environment at all times and respond consequently according to the circumstances. While there has been clear progress in recent decades, research continues in this context because most of the activities of a robot involves nonlinear processes and several variables. A 2 degrees of freedom arm is a case that exhibits certain control challenges and is the first step to delve into the development of more capable humanoid robots. In this video is shown how a 2 degrees of freedom arm is controlled by fuzzy logic, with the main goal of tracking a reference object of a distinctive color. The 8 pieces that forms the manipulator were 3D printed using the Ultimaker 2 Plus at UPB campus. 2 low-cost servo motors were used as actuators. Robot vision is provided by a high-resolution camera, located over the arm, emulating the vision of a human being. The main control system is implemented in Matlab, and is communicated through an Arduino, which controls the position of the servos. For identification, the system performs image processing through Matlab. The routine focuses on identifying red and blue. The eccentricity of the regions found determines if these are circles, corresponding with the spherical objects used by the system to perform the control task. The three-dimensional position of the objects are determined from some camera parameters. The arm has an open-loop control and another closed-looped, each of which is implemented by fuzzy logic. In the closed-loop control, there are 2 outputs and 2 controlled variables, which are the x and y position of the blue object at the end of the arm. The reference are the x and y coordinates of the red reference object. The error in x and y are the entries of the fuzzy control system, which gives the robot the servo angles at each joint. For this fuzzy control, a division is made into 4 main sections or quadrants on the reference object, which are each divided into 2 subsections. The position on these of the blue identifier object determines the control action to be performed, which is basically incrementing or decrementing the angle of each joint. The development and implementation of the fuzzy control is performed using the fuzzy logic toolbox of Matlab. The defuzzification is done by means of centers. The output set is defined by 13 memberships, each of which determine an increase or decrease between -17 degrees and 17 degrees. The open-loop control allows the arm to be positioned very close to the reference object from the prior knowledge of the angles to be executed by the servos to achieve that position, taking into account thus nonlinearities presented by the system. The control executes the open-loop action if the distance between the reference object and the identifier is greater than 5 cm, otherwise it runs the closed loop, where the action is faster. And then when it is close enough, finer error correction is made. The first test consisted in tracking the red object reference by the blue handle located at the end of the arm. This was done slowly, moving the first manually. It was demonstrated the arm slowly followed the object, matching them with an error virtually 0. Only for short periods of time was observed that the camera did not visualize the colors, but as fast as they were found again, the control action is resumed and the error produced was corrected. In this test, complete system stability is observed. The arm never moves indiscriminately, even when the respective objects were not observed. Some perturbation tests were made in order to evaluate the system's robustness. In this regard, while the arm performed the control action, was strongly moved by hand, taking it out from the path that it was executing, but it was observed that quickly returned to its original position, this due primarily by the fact that the implemented control corrects the position immediately when perceived the deviation generated, and second, because the servo itself internally has a PID control that keeps it in the position commanded. Another disruption was generated changing the reference object with a square red sheet of a larger size. It was noted that most of the time, this is not recognized and therefore does not change the position of the arm, only at certain times tries to move its arm, but soon returns to a neutral state. Furthermore, by covering the blue object identifier, there is no disturbance, that is, the system in this case is immune and remains static. Thanks for watching.